Hey everyone, my discussion starts in 10 minutes, but before that, let's let's try and see if we can learn how to tackle this educator problem, map of names. This one's pretty simple, hence why I'm throwing it in. I think, I don't know why I'm making a video about this, but I might as well. Uh, we are using maps to make two methods. Let's take it step by step. First with method one. So we pass in an array of strings and the length of the array and have a map that maps string lengths to a stack of names with that length. Frankly, I think it's pretty intuitive by the explanation. So let's create a map to return int stack string. So remember this maps, we'll call it length. This maps, well, okay, let me write my code. X is length and length. Okay. So this map maps lengths to uh to words. So at each point in the array, I want to first get the length of the word in that index. So array x dot size, right? That effectively routes me to the correct bucket in that map. And then to that stack that's now associated with that size, I want to push in the actual word itself, so just array x. And then we return lengths, lens, or whatever. I just want to say, never use a stack if you're doing something like this. You'll see it here. I think it's much nicer to use like a set or something in this situation, but alas. Uh, where were we? Okay, so here, now we want to put or grab a value and effectively check if it's inside of this map. So first, we know that a string value is going to be contained inside of the stack corresponding with its own length, right? So let's first, actually I'll go stack string names is equal to object value dot size, right? We're taking the size of the string because we know the bucket that string has to be under. It's underneath its own size. So when we're searching for a string, we just look at its size. Now, if we just had an array here, or if it was just a set, we could use dot count to check if it's in the set. We can't do that because we're instead operating on a stack. So what we'll do instead is we'll just pop everything off the stack over and over until we find our name. While names is not empty. So if it turns out that we pop everything off and names ends up empty, we'll return false because that means the name wasn't in the stack. However, if names doesn't end up being empty, or rather, if we see that names.top is equal to our value, we found a match and we can return true. If that's not the case, which I'm going to have plenty of time. Or and then if that's not the case, then we know that the top value doesn't match. We'll then pop that top value off and try again if there's another value with the next value. So this will just loop through all of the values on that stack by just popping it off. And then if we find a match, we return true. Again, we use this specific stack because given a string value, we know it'd have to be underneath the stack corresponding with its size. And so when we're looking for the stack to search in, we search with that input value size, just like we did here when we inserted. Let's run the code. This might be my quickest one yet. All right, ample time before my discussion starts. Yeah, I think this one's a pretty self-explanatory problem here. Again, I wouldn't actually like use a stack. If you're doing this, a set or an unordered set specifically allows you to do lookups in O of one time. And if you want duplicates, you can even use an unordered multiset. Whereas this is O of n and could even potentially be like destructive to your map. But regardless, it's the problem. All right. Thanks for watching. I guess I'll see you in the next one.